Coming up on Catalyst, technology that can see and hear depression. Could ghostly hallucinations open the door to new treatments for schizophrenia? And can brain stimulation help treat depression and even make you smarter?
If a picture is worth 1,000 words, our faces write a story with each expression. And mental health experts rely on their ability to read our expressions, our body language, and even our voices to help diagnose depression.
There's no diagnostic tests that say, yes, this person has depression. But when I'm talking to you, if I'm depressed, I convey that to you through changes in voice, facial expression, body movement. My eyes might be downcast, I might make poor eye contact.
These are the signs that indicate depression, and it's up to the clinician to recognise such patterns in speech and appearance to make an accurate diagnosis. It's a subjective approach with inherent limitations.
So we've relied on those sorts of clinical judgments, and clinical judgments are very dependent on the training and the sophistication or the idiosyncrasies of the practitioner.
Completely like a robot whose light has gone out.
GPs actually are responsible for most of the diagnosis, and the level of knowledge and experience of doctors varies a lot in the community. So we do know that we're missing diagnosis.
That's why a team of leading clinicians and computer scientists is developing a more objective approach, where cameras and microphones become the eyes and ears of the clinician. It's all made possible by recent advances in what's known as affective computing.
Now what that means is developing systems that can read and understand and analyze the affect, so the emotions, the mood of the persons that they're looking at, and quantify what's going on.
It's the same pattern recognition that clinicians currently use, but it's recorded by modern technology and analysed using sophisticated software.
It's a lot of analysis of facial expressions, let's say a smile or a surprise, and building an understanding of what are actually the facial models, the muscles underneath that make this happen. The theory behind that is that for a lot of people with depression, they're suffering from something called psychomotor retardation. And that really means that the control and the use of muscles in the body changes as a result of the depressed state. We often talk about the frozen face in depressed people, so a reduced amount of facial expressions. And the vocal cords and the vocal expressions, we have a reduced amount of expressivity.
There's difference to the volume, there's difference to the speaking rate, there's difference, for example, to the degree of variation in the pitch or the melody of the speech. There are those kinds of changes, and then there are also much more subtle changes that are a little more complex to describe, but we can extract them using mathematical techniques.
The team's largest study to date has assessed over 130 people, half diagnosed with depression in varying severities, and a control group with no history of depression.
We get people to watch movies, so they watch sad movies, they watch happy movies, they watch boring movies.
I'll start playing the video clips now.
Oh. And we're filming everything about their affect. That involves eye movement, eyebrows, blinking, smiling, flushing, heart rate changes. It's a wealth of information that we get.
And we found that is to be really working very well because the spontaneous reactions from people, that is really where the key information in relation to depression lies.
The other thing we do is we get someone to come in and interview them about their recent experiences, things that make them happy, things that make them sad. So we look at that interaction. How much does the person respond?
Can you tell me about some recent good news?
So it's basically everything that you can catch with a camera and a microphone that clinicians are already using.
We're very happy with our results. What we found is that if we just use individual cues, so let's say just facial expressions or just eye movements, we can reach up to about 80% agreement with the clinical opinion. Now, the interesting part really happens when we bring these different measures together. So let's say we combine facial expressions with the eye movements, with the head movements, with the vocal expressions, then we can reach up to 95% agreement with the clinical opinion.
The team is also working to measure the grade of the depression. This will help identify the more severe forms, like the disease state of melancholia, which the team has also analysed using brain imaging.
Where I think the great importance of the research will be in being able to decide who's got that disease-type depression, melancholia, where it's a very physical state, extremely physical. And for many centuries, it was actually more defined as a movement disorder than a mood disorder because of the way in which the face appeared immobile, there was a lack of light in the eyes.
So most people think when you get depressed, you get sadder than usual. That can be the case, but when you get melancholia, people actually lose emotion and they describe a complete loss of feeling and a dead feeling. And so what we see in that very severe type of depression, people don't look as happy when they watch a happy film, but they don't look sad when they watch a sad film. They just look the same more or less the whole time. And in the brain imaging we do, we see very distinctive signatures as well in those people.
So if we can come up with a system that detects the actual facial changes, and certainly our preliminary analyses are extremely encouraging, then that will aid diagnosis. And the distinction is of fundamental importance because the management of melancholia is not the same.
The aim for the next several years is to take their tracking technology out of the lab and begin a large-scale trial involving doctors and patients.
We're not talking about replacing clinicians at all. We're talking about something that a GP might have in their room or that a patient might have on their phone or at home that can add additional information about maybe how they're responding to treatment, how they're feeling in the morning rather than the afternoon, because that variation is important. So we're looking at embedding apps and other low-cost technology in people's everyday lives to help them monitor their own depression and to improve the diagnosis of depression.
We're very confident that we're on the right path to see this going into practice. And it's very exciting work to see that we're now at a point where technology can really assist people in their lives and have a major impact in their lives.
Have you ever had the feeling that you're not alone? That there's a presence in the room, something you can't quite explain? It's the stuff of ghost stories. Just the product of an overactive imagination, you might think. But could there be more to it? Well, we've come to Switzerland to visit an unusual lab. They've investigated everything from out-of-body experiences to phantom limbs, the phenomenon where an arm's been amputated, say, but still feels like it's there. Well, recently, they've discovered a new phenomenon, which is spookily a bit ghost-like. Indeed, the researchers have tricked people's brains into feeling an unexplained presence.
There were comments like, this is completely eerie, like there is some sinister being, something that has bad intent. But there was always a report of someone who wants to do something to me.
As it turns out, these are very similar to sensations associated with epilepsy and schizophrenia.
This is very similar to a neurological disease happening in some patients with peculiar brain lesions, where they report to have someone behind them.
Could understanding that feeling of being haunted lead to new psychiatric treatments?
This is why we took it from the clinic into the research lab, so we can have a similar phenomenon under controlled conditions. And we can advance more quickly in understanding what the real mechanisms are involved in such very strange sensations.
Now, before we get on to the scientific explanation for ghosts, you first need to know a little bit more about yourself. You and I are not what we seem. For example, I may think that my body is me and what's not my body is not me, but things are not that simple. That sense of me-ness is actually constructed.
The sense of self is the product of all these signals from your body, from inside and outside your body, being processed at the same time. And so it's from the coherence of these inputs that our brain generates a sensation of having a body always here.
But this unified sense of self can break down.
So what we do is we manipulate these signals to induce illusions. And in this way, we can study how the brain experiences the body and how the brain generates the sense of self.
Okay. So put one hand one side, one on the other. Okay. And I'm about to experience this firsthand. That's completely realistic. In this experiment, they're going to convince me a rubber hand is actually my hand.
Let's try.
Okay.
So what happens during the rubber hand, you feel touch on your hand because there is an experimenter touching your hand and you don't see that hand being touched. And then meanwhile, you see a rubber hand, a fake hand, being touched. So my brain needs to solve this conflict. And the way of solving this conflict is creating an illusion. That is, the rubber hand is my hand.
I can feel that. I can feel that completely. It's bizarre. Just very simple. And it's because my brain is seeing and feeling something and just assuming I'm feeling it in this rubber hand. So it's my consciousness, in a sense, is just leaping into this prosthetic limb. I now feel the stroking's finished, and yet I now feel I have no sensation of my real right hand. It's not there. Nothing exists on the other side of the partition there. I feel like I'm sitting on this side. That is my real hand. In fact, my brain has somehow invented an arm. I feel my arm is connected to this hand. It is bizarre. So I'm guessing if I had pain in my real right hand, maybe this illusion would in some sense allow me to dissociate from it. Indeed, that's just what the scientists are hoping to do with this research. They've developed a virtual reality system based on the same principle, which they're trialling on patients with chronic pain.
You're going to see virtual hand flashing in synchrony with your heartbeat.
Okay.
The idea with pain relief, if you sort of disembody your real hand, for example, you can, let's say, reduce all signals coming from that part of the body. For example, with a patient experience a burning and painful hand, you can maybe, by convincing them that the real hand is not this painful hand, but a fake one.
So I'm starting to disassociate from my real hand and associate with the virtual hand.
So the heartbeat signals is strong enough for your brain to induce this sense of ownership.
And it turns out that this ability to tamper with the brain could explain a whole host of strange phenomena. Now, what's all this got to do with ghosts? Well, the scientists think that feeling that there's a presence in the room with you has got something to do with the way your brain creates your sense of self. Ghost-like feelings are actually quite common.
Imagine walking a dark street in Sydney or 3 a.m. in the morning and you're not sure, but you hear some noises and you turn around to make sure nothing is there. It's really this convincing, this feeling. And each time you look back, you don't see anything, the sensation disappears. You look back to the front, the sensation reappears.
To find out how this feeling of a presence can be induced in healthy brains, Olive studied the brains of people who feel the phenomenon very strongly, those with neurological disorders like epilepsy and schizophrenia.
Very often, I think the large majority of feeling of a presence, it's negative. And in particular, in schizophrenia, where this phenomenon can occur, it's very typical, right? It's a demon, it's something negative, and this person may be inserting thoughts in my mind that are not my own. He's touching me, he's interfering with my liberty of taking decisions.
The researchers analysed the brains of 12 patients who'd experienced this kind of apparition. Their MRIs revealed lesions in areas of the brain involved in integrating the sensory information about their body's movements and position in space. Could the presence be a second representation of your own body, which is no longer perceived as me, but as someone else? A byproduct of sensory input not being integrated.
So again, you have two own body representations, one this one here, another one behind me, but since there's already a body representation here, there can't be two. If it's not me, if it's another human, it's got to be somebody else. So it's a very logical response, although it sounds very strange, of course, to say that somebody is there, although there is no evidence for this person.
To test their theory and conjure up artificial ghosts in healthy subjects, they developed a specialised robot to send mixed signals to the brain.
We're going to blindfold you?
Oh, OK, I'm going to do a blindfold. You didn't tell me that. I can do that too. The robot's comprised of two parts. A master front arm that's moved around by me, and a second slave arm that recreates exactly the same movements as the first, and it touches me on the back.
With the robot, what we do is basically you do the movement, and then we introduce this delay between the movement and the tactile feedback.
So now we have two conflicts. A spatial conflict, it is I'm moving in the front and I'm getting sensation on the back, and a temporal conflict, I'm moving now and I get feedback delayed.
This delay jams the feedback loop in the brain, distorting perception, causing a range of creepy responses.
It's starting to feel like it's got a life of its own.
From feeling the robot has malevolent intent to a spooky presence.
It's quite sinister, actually.
Because the only solution of the brain to solve these conflicts, that I'm moving here, I'm getting feedback delayed there, is there is someone else touching me.
I didn't feel like there was, a disembodied presence, but it felt like that robot, I wasn't in control of it. It was kind of doing what it wanted, which was slightly disturbing, actually, especially when I was poking hard. It was hitting me hard.
Would you say that it felt like some other agent having...
Yeah, it felt like it had its own separate agency. It wasn't me,
yeah.
It was doing its own thing.
My reaction was at the milder end of the spectrum, but some people have felt up to 4 phantoms in the room, and the feeling was so strong for a few, they asked to stop the experiment.
Yes, they freaked out. There was one girl who wanted to stop. It was just too strange.
If the researchers can create a feeling of a presence in healthy people, perhaps they could do kind of the reverse of that and reduce the hallucinations in people who suffer them. They could have a new treatment for schizophrenia. They wouldn't replace medications, but they'd be an important adjunct to them.
So if you have a patient who has auditory verbal hallucinations, he hears voices, could our system be used? The voice may still be there, but it may be less dangerous, less intensive, shorter lasting.
While it's still early days, the team's working towards a wearable system that combines virtual reality and tactile information to correct the misaligned signals, reducing the severity of the hallucinations.
This is very early for us. It's a direction that, because of the prominence of the disease and the lack of novel treatments, I think, in the last couple of decades, where we would like to make an impact. So the strategy would be, can we use and adapt this system we have to down-regulate hallucinations in schizophrenic patients?
Using electricity to treat depression is nothing new. Shocking and controversial in its day, electroconvulsive therapy rose to prominence in the 50s and 60s. But terrible side effects earned it an infamous reputation. By the 1970s, novel developments in antidepressant drugs shelved ideas about what else could be achieved with brain stimulation.
Treating depression is complex. Established treatments like ECT and antidepressants work for some, but not all. Now there's renewed interest in other types of brain stimulation to treat mental illness, and some say it may even make you smarter.
TMS, or transcranial magnetic stimulation, essentially involves using a pulsed magnetic field that passes into the brain really without any resistance. And when you apply a magnetic field to something that conducts electricity, you induce a current. So it actually makes the nerve cells in the brain fire.
In transcranial magnetic stimulation, if you put a magnetic coil on the motor areas of the brain, the firing nerve cells will make the patient's finger move. Apply it to visual areas of the brain and they might see flashes of light. But in the case of treating depression, the magnetic field is applied to the left prefrontal cortex, the part of the brain most responsible for happiness.
And what tends to happen then is if you're making nerve cells fire repeatedly many thousands of times, you make them change their activity levels. And that way we can very specifically target changes in somebody's brain in a way that hopefully has therapeutic benefit. Good morning. We'll get you all set up.
Depression is very complex. Initially, my doctor prescribed me with antidepressants. They helped me to a point, but I still felt that I could have been better.
We're just going to measure up your position for your coil.
Eventually, Jan underwent TMS therapy at Monash Alfred Psychiatry Research Centre.
I went on to a trial that allowed me to have treatment each day, and I came in here after work.
So what does it feel like, Jan?
Just feels like someone's tapping on the side of your head. It's not painful. After about the third session, I noticed I was just falling asleep.
All right.
And felt quite relaxed.
Have a nice nap.
Yes. I was quite surprised at how some of my thoughts were changing. All of a sudden this thought came into my head, oh wow, what a great day. And I kind of looked around and thought, where did that come from?
We tend to find about 45% of the patients we treat get a really substantial antidepressant response. Another 20% or so get benefit without it perhaps being life-changing. And at about 35%, the patients don't respond at all. OK, you're all finished, Jan?
For patients like Jan, TMS is already available as a treatment for depression at outpatient clinics across Australia.
But researchers are trialling a similar therapy called transcranial direct current stimulation, which may also help people with depression.
Okay, I'm just going to put these on, Jenny. Sorry, it's a little bit wet. Transcranial direct current stimulation, or TDCS for short, uses a really tiny electrical current. We apply TDCS through two pads placed on the head, roughly about here and here. And it's just a gentle, ongoing stimulation that, if you like, sort of tunes up the brain cells.
Unlike TMS, TDCS doesn't use a magnetic field. Instead, a weak electrical current is thought to enter the brain, subtly influencing the way brain cells interact with charged particles, or ions.
All of this is kept in a very finely tuned balance. So what seems to happen when people are depressed is that fine balance is being disturbed. Okay, that all looks good, so we're going to start. So what you do by restoring the balance is that you're restoring it to a normal level of activity.
I have been ill now for about 15 years. Once the depression hit, I often simply couldn't bear to talk to people. I couldn't open my mouth without crying.
Jenny took part in a research trial of TDCS at the Black Dog Institute, and although the study is still underway, Jenny seems to have received some relief from her symptoms.
It's been so subtle. Perhaps my ability to listen has increased. Perhaps my ability to express myself has increased. It just seems that there are these little repairs happening along the way.
The potential to use direct current stimulation to treat mental illness is yet to be fully realised. But one of the more interesting claims about this technology is that it may accelerate learning, improve memory, and generally make you smarter.
First became interested in TDCS in my undergrad, where it was referenced quite a lot in neuroscience and psychology as a relatively easy, safe, and effective way of manipulating brain function.
Peter isn't alone. TDCS devices are widely available online, and there's a growing subculture of home users who claim that TDCS can improve cognitive function.
Commonly, I might use it because at the end of the day, having to do some extra work, in that case, prefrontal stimulation does seem to have a slight improvement on my vigilance and attentiveness.
But is direct current stimulation safe to use at home?
We just don't know. What we've done so far doesn't show any risks, and if people are taking these devices and using them at home, they have to be aware that doing that is something that's completely outside the realms of what has been studied or what we know is safe.
But aside from the potential risks, one researcher questions whether direct current stimulation has any effect at all on healthy brains.
I started research with TDCS about 4 years ago, and at the time I was really, really excited about this technology. And over the course of about 2.5 years, I tried any number of things. I did auditory threshold testing, visual threshold testing. On this task, your job is just going to be to take a look at the squares as they pop up, try and remember what order they came in, working memory, reaction time tasks, inhibition, attention, just any number of studies, and I just never got any solid results.
Searching for evidence that direct current stimulation actually worked in healthy brains, Jared conducted a quantitative analysis of 15 years' worth of TDCS research.
What did you find in this analysis?
In our analysis, a study had to have been repeated at least one time by different groups. So what we did is we pooled all replicable data out there. Unfortunately, what we ended up finding, regardless of how we chose to pool things, was nothing was really coming up really strongly significant.
So you're saying you weren't able to find any notable effect on direct current stimulation on healthy brains to improve cognition?
Yes. So now again, there are studies out there that do show improvement. Some say it did improve it, some say it didn't, some say it impaired it.
Yeah.
And when all those things come together, you tend to even out.
Jared's analysis has been divisive in the field of neuropsychiatry.
So what he was pointing out was, if you put together all the studies, the effects are not as impressive as, say, the early few studies, which I think is a valid comment. But I think the wrong way to understand that study would be to say that the whole thing's a waste of time and that nothing is happening. I don't think that's correct either.
Well, I wouldn't say at all that this proves that TDCS doesn't do anything, and I wouldn't say that it proves it does do something. The only thing that this report will say is that there's not compelling evidence to suggest that TDCS is reliable. So it's possible that it does something, it just is really hard to find or narrow in on what that something is.
Whether or not brain stimulation works in healthy brains, this technology is already giving hope to many suffering depression. And future research promises to further our understanding of the human brain.
Next week on Catalyst, have you ever tried to lose weight? And when you did, put it all back on? Mark Horstman investigates new discoveries overturning the conventional wisdom that beating obesity is all about eating less and exercising more.
If this program has raised personal concerns, you may wish to contact one of these counselling services for further information or advice.